All right, example 5, the arrowheads indicate the lines are parallel, find x. Okay, notice this time we're not dealing with angle measures. We're dealing with segment measures. All right, we have 3 parallel lines. We can have 4, 5, 6, 7, 8 parallel lines. It doesn't matter. But you have multiple parallel lines cut by multiple transversals. This transversal measure, the measures within the parallel lines, is proportional to the transversal measures on this transversal within the same set of parallel lines. What that tells me is that these two sides, 2 and 8/3, are proportional to 5 and x. And all that means is that we can make a proportion. That's fraction 1 equals fraction 2. And to make the proportions real simple, use some orange for this one. This fraction here equals this fraction here. That's how you make the proportion. We want to extract that from the problem so we can look at it a little easier. 2 over 5 is equal to 8/3 over x. 8/3 is not the friendliest number in the world, but it's a fraction. We know how to multiply and divide and add and subtract fractions, so we shouldn't have a problem with it. Keep in mind that when you get a proportion, one fraction equals another fraction, this fraction represents the numerator, that's the denominator of that fraction. So when we cross multiply, this product, which is 2 times x, equals this product, which is 5 times 8/3. When you multiply a fraction times a whole number, only the numerator is being multiplied by the whole number. So 8 and 5 make 40, which is over 3. 2x equals 40/3. I can divide by 2 because that's what I'm supposed to do, right? But since I've got fractions in the problem, I would probably prefer to multiply by a half. My entire intention when I'm solving an equation, I want to make this number become 1, right? What's 2 divided by 2? What's half of 2? 1. I can make it 1 either way, right? Since there's a fraction alive and well in this problem, I'm going to multiply by a half on both sides to do what I want to do. So on this left-hand side, 2 times a half makes 1, leaving me with x. On the right-hand side, I can actually reduce the 2 and the 40. That gives me 20 over 3. Those are easier with whole numbers, but they're not that difficult with fractions. Just know that when you have a fraction in an equation, multiplication by reciprocal might be easier than dividing by 2. 40/3 divided by 2 also equals 20/3. Just not as obvious. All right? Now, here's where the difficulty of these problems is. This problem mixed with that problem. They're going to put them in the same problem in the homework. What I'm telling you is they're going to do this. They're going to give you parallel lines like this, this, and this, and that, and that. They're going to say this is 38 degrees, and they're going to say this is 149 degrees. And they're going to say this is x and 14 and let's go 12 and let's say maybe 8. And they're going to say this is y and this is w and z and q. There. All right? That's what a problem might look like. Now, what I want you to do is have this. That Q's not very good, is it? Let me try drawing it again. All right, let's just do this. Let's go green. Oh, and let's even do this. Let's go purple. That's what I need your brain to be able to do. Pick out things that affect each other. Everything in green, x, 14, 8, and 12 are all segment measures based on the transversals inside the parallel lines, right? So the green stuff has properties to it. And the property with that is that this fraction, x over 14, is equal to that fraction, 8 over 12. So I would write x over 14 equals 8 over 12. Cross multiply, figure out the answer, right? The blue stuff all has to do with this transversal here. We have an acute measure of 38, so we have an obtuse measure of 142. 38 plus 142 makes 180, right? These angle measures don't affect this transversal because that's a different transversal. Alright, so all the acute measures are 38, that's acute at 38. All the obtuses are 142, but Q is also acute, right? So that's also 38. So just like that, you figure out Q and Y. Over here, the purple one, that's 149, so how big is this? 31. So all the acutes are 31, all the obtuses are 149. Z is obtuse, 149. W is obtuse, 149. Okay. So the point is that you might have a whole bunch of stuff happening in a problem, but all the green stuff gets you an answer, all the blue stuff gets you an answer, all the purple stuff gets you an answer. You have to have that vision to be able to see what affects what. And that's where these problems get challenging. Everybody knows all the properties when they're just there one at a time, but when they're all thrown in the same mix, sometimes people get a little bit flustered and there's too much to look at. So focus, everything on one transversal angle-wise affects everything. Everything on a different transversal angle-wise affects everything on that transversal. Segment measures only have this one property. So if you see segment, no angle, just x, 14, 8, 12, proportions, cross multiply to get the answer. All right, that's where the challenge is in these problems, not the individual properties, but when they throw it all together, which guess what happens in today's lesson? I remember right from last year. This homework assignment, they just throw you right in the deep end. So be ready for that. That's how you handle it.
I had a question.